P3-41 is a little scary. Has all this geometry. Kind of looks like this front face. And when we do the numbers, I believe this front face is set back. And we don't really know where this is terminating. So we have the T-slot over here. We know that we have this this notch going on. Does it go all the way through? Well, T-slot may. The groove may not, may terminate back at this face. So we'll have to see what it looks like when we get into it. We are in metric, and this has a pretty good feel to be a layout sketch. File new, part metric. Go into the front plane, and first thing is just to get an envelope, start it on size. So 60 by 100, and what that'll let me do is zoom to fit, and then we can start putting in other geometries. So the angle on front can go in at 20, and then we have 230, so base edge. Okay, what else? L on the keyboard for the line command. We'll bring that at a little bit of an angle. Watching one of the issues is that we're going to start getting a lot of inferences. So coincident, but not midpoint. So that's good. A distance of 44 to the edge, and the top is another 30. Alright, the T-slot then, let's just go rectangular, and that dimension will be 20. Let's see, 4 on the height, and then position. Well, kind of looks like, and there we go again making assumptions, but kind of looks like it's on center with the threaded hole. And so if that's the case, then our dimension would be at 17. And I minimized that when I really just wanted to move it out of the way. There we go. So that being the case, let's go into the center line. And we'll pick an edge and we'll just go ahead and bring that all the way up. Place our dimension. Yeah, 30 to the edge. It wasn't. It was 10 millimeters to center. There we go. 25 millimeters. Alright, so 25 millimeters, the 10 millimeters that was looking in here actually is splitting the 20 millimeters for the sides, and then the bottom of the groove is 10 millimeters. Alright, so that goes to 25. That looks a little bit better. We can pick the midpoint, make it coincident. And we'll drop in a couple of the T-slot lines. Go ahead and mirror those. So that was 10. And that depth is 5. Okay. Alright, so the N was 7, and 12 for the rise, except that picked up an inference, and I know that because it went fully defined. So which one? And that can go to 12, and really because those are going to be the center of the hole, that can be center line. I'll just double check. Alright, and then another center line. Well, that grabbed midpoint. I'll let it have it, go back and delete it. Also grab midpoint of the other side. Yeah, pretty much. So we want coincident. And then that is 30 millimeters to the intersection. Okay, so that gets some geometry. Let's see. Well, that one went midpoint. It's not really showing me parallel. There's my inference for parallel. And it's just a touch off center line. And based on the way that this is dimensioned, it won't be between the two lines, it'll be between the two endpoints. Okay, and that'll make a little bit of a difference on the geometry. So center of the hole, offset, slot. And then assuming that those are going to stay parallel, nope, not allowing me to pick it up. There we go. Then that dimension can be 16. Let's see, the down angle. Alright, so that does have a little bit coming back this way. And if that's the far end, and that comes off perpendicular, and kind of hard to tell on the dimension what it's looking for there, comes back across to the intersection, horizontal. Okay, so 5, and then the height becomes 12. We have a length across that line of 25. So we're going to need an intersection. Let's see, diameter is 8 here in the corner, and I have to assume intersection. Okay, so rather than trimming those out, I can put a point, but then I can also go to split entities, which is tools, sketch tools, split entities, and we'll split the line and miss it. Bring that one back. It can go to construction. And then what that'll let me do is, and miss. So really wanted a linear dimension there, so stay close, 25. It's not too bad. So starting to get some definition. Okay, and then we'll go let's see, 10 millimeters down and 8 millimeters in. And grab the midpoint, so we'll get rid of that. Switch it to coincident. Okay, so we've got that. Let's see, there's a 2 millimeter gap, but that one's going to end up being vertical. So from the end point to the line, 2 millimeters, and then another 3 millimeters. Let's go ahead and put the 22 height in. And we'll go ahead and close that off. And we have a 2 millimeter on the end. So that's where the inside edge stops at. And we need to figure out where the angle back goes to. So 60 millimeter. I'll stop there. 3 millimeter. Alright, so that gives the depth. Oh, still managed to miss it. Alright, so, not horizontal. Okay. So we're going from that point over and then back. Okay, so a whole lot of lines, and we'll try to start making definition out of that. So since this is the layout sketch, and I just invested 10 minutes into making that, I'd like to make sure I don't crash and lose it. So this is going to get saved. 341. Okay, so generating the first geometry. We will go back to the front plane, or into the front plane, and we'll just trace over top. We can convert geometry here in a little bit. So if I trace, I'm just going point to point, making coincident at each of those endpoints or intersections. Okay, so that gives me my first piece of geometry. Features extrude. We're going to go ahead and take it to the back. 56 for the depth. All right, and then the front face in here that matches up. We're going to end up with a depth backwards off of that face. So, well, let's go ahead and sketch off of that side. We'll bring it forward. Okay, so convert entity. Convert entity. I think I'm going to go ahead and bring it this way. And if we get too much, we can always trim it out, but grab my endpoint, and it's warning me of the first. Drag the endpoint. Kind of surprised it let me have that one. Okay, back to the geometry. And the intersection. This one I think we will trim. So convert entities, and then trim entities, trim to closest, moves the notch. Oh, you know, that was tangent, wasn't it? Darn it. Okay, so if we make that correction here, okay, so we take the on edge off, and let's see, one of the coincidences, I'll bring that back and go tangent. Okay, so this is still 25 millimeters. That comes back to its edge, and I'll have to correct that in the layout. Alright, so based on our dimension, we have 16 and 40, so 10 millimeters shy. So features, extrude boss base. This is going to go 46 millimeters. And we'll reverse the direction, bring it up to the geometry. Okay, on the 46 then we have a notch that comes out from that point, so sketch on the top face. Start from there and come over. We'll let the sketch figure out the width, and since, I don't know what I picked, that must have been the bottom of the slot, so Control Select, and then those become coincident. Depth is 15. Okay, so that gives us the notch, and then now we could use that, but I think we'll just go with the extruded cut. Set that the direction is along that edge, and it goes through all. Okay, so far that's looking good. Control S to save. Alright, so another piece of geometry. Let's see, that one's 18 off. Interesting, that's going to come up with all those steps and without any radiuses be very difficult to manufacture. Alright, so pick up where we left off. I want to overrun this one just a little bit, and we'll bring it forward some distance. The over and the back and the tie-in. Alright, so as long as it's intersecting enough that I can compensate for the angle. Let's see, at the very least it would need, I can project that edge into my current sketch. At the very least it would have to be collinear with that. Alright, so that edge and that line go coincident. And that point and that line go vertical. That point and that point go vertical. Alright, and then we need some depths. So 40 for the depth. We had 16 to get to that edge. That looks pretty good. And then our intersection is to 22. And reverse the direction. And just a little bit shy. That is some strange geometry. Okay, well, coming off the back at this point, I should have almost brought it forward, but we will pick up the edge. And even though I'm sketching on this back face, collinear, that notch, that slot, is going to be able to extrude. The from plane offset 18 millimeters, and we'll see which way it goes, and then reverse it, and then reverse the blind in condition, and it goes 20 millimeters, so it gets into the geometry. So in another step, strange geometry. And we'll hit the Control S to make sure that this gets saved. Alright, I think that's the majority of the solid. Let's see, we have an M7. It's not defined as depth or as a thread, so S key, hole wizard, to depth, drill sizes will go down to 7 millimeters. Up to next, set a position, find the intersection, go ahead and accept. You can see that it goes through. Let's see, was there another M7? Oh, 2 places. Well, it almost looks like, well, they either put shading, I guess they just put the shading on it, but it didn't call out as threads. So, that being the case, let's go ahead and instead of going back in, I will edit the first sketch and we'll put another point into the sketch. That places it on all the way through. Even though it's out at this sketch plane, it'll find its way all the way through the geometry. So that does the same thing as editing the feature, going into the position, adding the sketch point out of the whole out of the positions. Next one is the M12. So we pick the diameter, we'll stay with up to next, find the intersecting center lines for geometry, go ahead and hit OK. Should have the same parameters. M12, up to next, position on that face. And then dimensions are 28 in, and 15 over, and picking up that angled edge. That's not really a datum that I would be comfortable with. I really would want to try to bring that off of an edge that we can actually measure from or pick up. Alright, that looks good, and I think that's got it. Okay, so we go back and we hide the layout. For design for manufacture, some of this geometry, how much should we end up with here? About 3 millimeters. That 15 millimeters, if it could go to 8 millimeters, would clean up all the way around that edge, and then machining in this position wouldn't end up with a step. If that was locating something, or not just for clearance, then the other option would be bring this up 3 millimeters. If we can't do either of those, then both of these internal edges, and there is no fillet call out, but both of these internal edges at the very least would need to have a fillet. And 56 millimeters is a long ways for this small 2 millimeter geometry, so that one's going to be questionable. Alright, so let's go ahead and put a 3 millimeter in there. Alright, so it has some kind of blend. 2 millimeters is about 80 thousandths, so getting into that corner, well, there again, what do we have for distance? A little right there at 2.2, so let's see if we can get a 3 millimeter in there. Alright, so even with the blend, if it can come over on that side, it's a long end mill for 6 millimeters, so 2 inches. Let's see, we had 4 millimeters, 56 is a little over 2 inches, and then the 8 millimeter on the diameter is 4 millimeters in corner. We're into wire EDM territory on some of this, so in that case I'm going to have to go in and burn out that geometry. On this notch though, there's not a lot we can do there. The wire can't go through. End mill's going to have to go through a nibble, and being 30 millimeters deep, pretty close to a little over an inch. That's going to be a problem for the design. So, all right, so that last fillet is a maybe. So I will suppress it from the mix, and then the big issue is whatever this geometry is, maybe we need to make this piece separate. Locating pins, fasteners, somehow bolt it to that face. On that fun piece of geometry, still have questions on the design review, and come up with some better method. So I'll save it one more time, and we'll take a look at 342. 342 has the angled face. So this kind of L-shaped piece, and then say we just draw the kind of the trapezoidal shape and extrude it up. Alright, so we'll go ahead and close that. This one is in inches. we have an inch again. So new, part inch. Let's see, from the right plane then, sketch. Up, over, back, down, and over. Put some dimensions on it. So we're 0.75, or no, 0.88. Again, with the two decimal places, we have to decide what kind of tolerances we're going to hold on this piece. If it's casting, it could be pretty well wide open. If we're machining, well, if we're machining, we really have to think about that angled piece, because that's a lot of material to remove. And if we could make it a separate item and bolt it in and get the same kind of rigidity, strength for whatever function, then we'd want to go that route. So I'm going to take this out to the 3 decimal places. So 0.88 is 7/8 is 0.875, and our overall length is 2.75, and then the height 0.38 goes to 3/8, 0.375, and then the length 1.25. Alright, and then features, extrude, and doesn't really matter, we'll go 3.25 on the length. Okay, so 2 holes, 0.75 2 places, doesn't show it on the back side. So let's go ahead with the angle geometry. And if we go parallelogram, we should be able to go pull that off and go to the side. Alright, so anytime you're working with the other items under the rectangle, keep in mind that each of the last 3 will require that you do an additional drag to further define the geometry. 0.25. See, 1.5 inch, 1 inch both sides. Okay, so I guess that's how they're setting the angle. Alright, so that updates. Features, extrude, 1.5 inches. We have our shape. Alright, so diameter 0.75, 2 holes, and then we have the 0.75 2 places. 0.375 for 4 holes, so it'll be a mirrored pattern. So let's go ahead into Esky, the hole wizard. We'll look at this from the top. And I need to switch back over into inches. And we'll pick up the fractional drill sizes and go to 3/8. Alright, and then show decimal values. Also will pull up the decimal equivalent so that you can verify you got the geometry. We'll make this through all and face to put it on. Alright, so when I go to generate this center line, I'm going to have a different midpoint because I could have put that on first. But let's go ahead with the select midpoint. It can be projected into current face, and those just become coincident. And I missed. Let's go ahead and grab those. Mirror the entities. We'll go 0.75 2 places. And then 1.25. So let's go ahead and get those vertical. And then it's given as 0.75 off of the front edge. Okay, so those look pretty good. Alright, and then the 0.75 diameter. I'll open up the sketch. It goes normal too. They're showing, let's see, off of the top, and off of this back edge. So picking the face, S key. Oh, I went back into the sketch. Let's stay with the whole wizard. Control 8 goes normal 2. Fractional drill sizes, we're going to jump up to 0.75. Set the position. Oh, and got a little butt nappy there, so we'll just jump back into the sketch. And apparently, nope, those aren't moving together just yet. Horizontal. So not quite sure what I picked. Okay, so off of the edge, 0.875. .5625 for 1 9/16, and 0.75 from the top. So that doesn't quite look like theirs. Double check the numbers, make sure I didn't. No, it's definitely not centered, but it one hole is shifted quite a bit. So that'll be a question mark for design review of where that value came from. All right, same thing when it gets into the assembly. When we have more information, we'll do a little bit more with it. Kind of looks like there were fillets, but I don't see any call out for fillets, so save it and go 342. Okay, quick double check and we'll go. Alright, 343. Given that this is 10 millimeter plate, that's going to be too thick to bend. It's also going to be a pain to machine with the angles, but let's go ahead and see what it looks like. So 30-degree angle. Given that this is our flat, I'll kind of start that at the midpoint and see where we get to from there. This angle, that angle need to overrun each other, and then the holes aren't a big concern. And it is a metric part. So File, New, Part Metric, Front Plane, Sketch, Line. Let's just go ahead and set it at the midpoint so that I have room to maneuver. And one goes that way, and one goes that way. Alright, so my angles, based on what I'm given, see if we go to those, I don't need to do the end point. And this one, I will need the end point if I want to stay with the 30-degree dimension. Alright, so lengths has, and this is going to be the top of the part. Alright, double checking for the offset. Okay, so based on the offset position, 40, 50, and 53. Alright, so as much fun as that is, I'm going to select the chain, go into the offset entities. It's 10 millimeters. We'll have it cap the ends with lines, and that will generate the rest of the geometry. Okay. And then our extrusion is 40 millimeters. So we go to isometric. That's pretty close. Maybe not perfect, but pretty close. Alright, so I want to overrun this lower edge at least for the notch, and then overrun the top. So that being the case, I'm going to go into the wireframe. We'll get back into our corner rectangle, and I can select midpoint, select my line, make those midpoint, Oh, and I don't think I wanted to infer that relation, so I need to double check, and I pulled the wrong dimension, so, oh, nope, not yet, 16. Alright, so that being the case, yeah, it did infer somewhere. Alright, so I need to get rid of that coincidence, and we'll pull that back. Alright, so off of the edge, 13 millimeters. And again, from the detail side, we need much better datums to manufacture from. So extrude cut, and this is going to be an up to next. Alright, on the intersecting sketch then, I'll go to the lower edge. Should be able to pick up that same geometry. That'll make the overlap intersecting cut 20 millimeters from the top. And let's see what that looks like. Extrude cut, up to next. Okay, so that gives us the shapes. The other thing is without any of the radiuses, this is already a big chunk of material that we're going to lose quite a bit of stock from. So if we can save a little bit on the machining, we really need interior radiuses on those on that pocket. All right, 10 millimeter diameter holes, so back to metric. Drill size, scroll down, 10 millimeters. I'm having fun with up to next, so we'll stay with up to next. 20 millimeters, so these are on center line, and we can keep them on center line by going midpoint to midpoint. Bring those to coincident with that center line, and then 15 and 20. Go ahead and accept. Alright, so design for manufacture on this part. Look at it from the front. One of the things that I would like to know is relative stock sizes. So if we go into the sketch, pick up the other rectangle, and I'll go 3-point corner rectangle. And we'll try to find where this touches the points and yields the kind of the smallest piece of material. So if I have to machine this on in, I'm going to go a little bit over size. Let's see, that'll be another larger point. And we'll go coincident. And depending. Okay, let me have the point. Nope. That's just messing with me. Okay, let me have it. There we go. Coincident. Alright, so bringing that up. Well, we can go ahead and try it. Coincident, coincident, coincident. So that being the case, our minimum stock 131 millimeters, pretty close, not quite 5 inches, 6 inches, and 32 millimeters, 1.25 inches or so on the width. Alright, so we're going to lose a lot of that material, and there's no easy way to get into it. So machining from this orientation, I'm also going to need internal radiuses on the corners. If we start off with the block, we have bin lines, but we also have more setups. Alright, so I'd have to do one setup, remove this material, come over, set up an angle, remove this material, make that blend, set up on the end, remove whatever little bit of material's there, and then kind of the same thing is bring it in. We got some long lengths here. So this would be a manufacturing challenge piece. So still have more decisions to make on that piece. It's not done yet. All right, so 343. All right, 344. All right, so some strange angles. Looking at this, what jumps out is that I can generate kind of this profile shape and then come back and cut that end off. So let's start off with that. We'll go File, New. This is an inch piece. I'm going to round to 3 decimal places again, or I'm going to go to 3 decimal places. We'll go to the right plane. And we have a height of 2 inches. And across this lower leg, 1.75. And we'll switch back over the line, and coming off of that angle, perpendicular, back up. All right, so looking at this corner, this, well, based on length, 2 1/4 and 1 1/4. So 3 1/2, that's too long to machine. So the angle, whatever the angle is, can't even really get a form cutter in there. So we're back to having the discussion about wire EDM. All right, so 0.5. And length is 1.625, 1 5/8. And do we have an angle or a depth? 30 degrees. All right, so off of the top edge, coming down 30 degrees. That will give me the shape. So this will automatically send it into contour and region, basically leaving this as an overhang. So when I extrude boss base, we pick the region, and this overall distance, we said 2.25 plus 1.25, we'll get 3.5. Going back into that sketch then, go back into the extrude, pick the next piece of geometry. It's just the sketch region 1, so 2.25. Slows it down. And then on the edge, we're going to pick up that geometry, and it's kind of a toss-up. So let's see, coming off of the end, 60 degrees. Let's move that back up before I apply the dimension. Can sometimes change the state, but positive to negative. But if we don't have to, it's usually a little easier. All right, features, we'll leave it open, extrude through all both. Go ahead and accept. 375 by 1/2 inch deep, 4 holes. So picking the face, into inch, stay with the fractional, 3/8 of an inch, and blind in condition, 0.5 depth. And again, 0.5 is to the shoulder. 1 inch by 0.75 on the pattern. All right, so those two horizontal, those two horizontal, those two vertical, those two vertical. .75, 1 inch, and then there again picking up off of kind of the weird datum, the lower edge, and tend to go to the outside, 1.75, so it would have worked either way, symmetrical, just strange. All right, so 0.63 off of our leading edge, so 0.625. And this is probably one of those instances that if everything adds up right, that I will make this dimension driven. I'm going to say don't show again, so it'll ignore that particular pop-up from now on. But if I had left this at the 0.63, then this would have read 0.625. If we're looking for symmetry, then I would really like to see these numbers be the same number. Alright, so we'll go ahead and set it. And then, let's see, looking at it from the end, one thing to keep in mind is that the Hole Wizard does generate the drill point. So 118 degree drill point at its depth. If we use 135 or 140, some different geometry, that would be the minimum depth that we would want to machine to. 3/4 inch by 0.25 deep. 2 holes, both bottom drilled. All right, so those don't quite go through. Bottom drilled. So I'm assuming that means since we don't see a drill point and probably would go through on the 1/2 inch anyway, this is going to be a pocket. Alright, so 2.25 and 1.13, that can be centered. And then 0.88 and 1.63, we're going to go right to the midpoint, and then we'll verify that dimension. 0.75. Alright, 813, so wasn't quite centered. That's right, 1.75 would have been halfway, or the length for halfway. Okay, so take off the midpoint. I already have a dimension. I'm over to other, uncheck the driven, double click, 0.875, and then we'll just make sure that it stays coincident. And features, extrude cut, 0.25 deep. Alright, so not that I would do it very often, but I can take that geometry and Control C, place it on the face, or select the next face, and Control V. It's going to warn me about the relations that it can't infer because or solve because it has changed those dimensions. But I should be able to come back to midpoint, and now. Let's see, is that still set to vertical? Yes, so vertical goes away. And we'll switch over to horizontal. Find the midpoint. And even though it's on that face, okay, not exact. Let's go back to midpoint. And 0.75 from the bottom. And then go ahead and accept. Alright, so whatever that notch relief is doing, that would be a question for design review. 344. And 345. Alright, so 345 is one of the more interesting. I think it's been done in a few previous videos. So we're going to start off with our cube shape, our rectangular prism, and then kind of work back from there. So we're going to need some geometry for the direction of the cut. Since this is the high side, I can probably go ahead and include the 30 degree. And then come across this back edge and tilt it down and then set a direction of the cut. See what that does. Okay, so File New, and this is in metric. Front plane, sketch. We'll draw the rectangle. and then remove the horizontal dimension, tilt it down just a little bit, 60 millimeters on the front, 85 on the side, and then 30 degrees. We'll go with the end point and the line, set the direction, and then features will extrude, and this is going to be 45 millimeters. Okay, so on the back side then, we go into the sketch and tilt this down 15 degrees. And should be able to leave that an open profile. We'll find out here in a second. And it's going to follow that line. So features, extruded cut. Stay through all. Side to cut's okay. Direction of cut is along that edge. And we'll see how much that dips. Okay, so that gives us our compound angle. Alright, so the square is a little interesting. Say if we go into this this face and open up our sketch, we're going to be dealing with our points. So let's go parallel first. And there's going to be some interesting inferences. So, alright, so vertical, and then that should be vertical. Those two ended up parallel, so I'll make that parallel. And then vertical. Alright, so I think I have this. Off of the side then is going to be, oh, went to the wrong side. Alright, so let's get rid of that. 18 millimeters. And then another 18 millimeters. And then we have 21 millimeters. And position puts it at 30 millimeters. Okay, so kind of a strange location. And that gives me the prism, but it doesn't give me a direction. So let's go ahead and accept. I really need that, that location first to generate a plane. Okay, well, we'll see what we get. Alright, so in the features, reference geometry plane, we'll start at the front, bring it in some distance, open up our sketch, go into the line geometry, pick that edge that, or that vertex that has the 15 millimeter dimension. Okay, and even if I have to generate that geometry, say I don't know if that has to exist before or after. So let's go ahead with the extrude. I guess it doesn't matter. Direction of the cut, and then up to vertex. So problem is it didn't end up being flat. So it kept following the geometry. So not exactly what I wanted. Okay, but we still need that geometry, so we're going to hide. And we'll call this the angled face, and this the height. Okay, so they're going to participate in the construction. We just got to get it there. Select the chain, convert the entities, and that forms our square on the bottom of the part. Features extrude boss base up to vertex will give me to the end point. Positive into a positive is no net gain, and it gives me my geometry. Okay, so the angled face sketch can hide, and the height can hide, and then that leaves just the notch through. Select midpoint, go to midpoint, and 12 off of the side. And 15 on the depth. Okay, I'm going to go ahead and save and bring that back in for comparison. The main complexity here is that they've generated this geometry in relation to that angled face, and on the compound angled face is difficult enough. So this actually ends up being, I thought it was a fairly nominal number, but not quite square either. So if we were expecting one thing, that's pretty much what the numbers give us. The other issue is, same discussion we've always had, is manufacturability. If this is a 3-axis part, then what kind of radiuses can I put in to generate this this shape along these edges without having to do multiple setups or trying to blend the geometry? And so let's go with a 3mm, and that would be close to a 1/4 inch end mill, trying to blend into that shape. All right, so what if scenario, we'll go ahead and suppress it, make sure it saves. Okay, doing 346. Just a couple more to go. Chapter 3. Alright, so strange shape, but not too complicated on geometry. 75 to the edges, and then do they give us perpendicularity? No. Try to figure out what's going on. Okay, so 2 intersection, and that one kicks back 240 degrees. Makes me wonder if it's perpendicular to that face. Alright, so we're going to have to make some assumptions if I don't see that dimension materialize here. Alright, so on the top plane, and really I would like to draw this along one of the datums, but I guess that front datum is about as good as anything. So part metric, top plane. If we go with the circle, 30mm as the center. The dimensions are off of the origin. So geometry up, over, and back, and bring it to the center. And go center line to midpoint. Make sure it's vertical and it's coincident to the origin. These two get mirrored to that one, and our dimensions go 35 and 35. Those okay, for the angles, then we can get to perpendicular. All right, depth-wise is 25. So let's do a virtual sharp here. Select the 2 lines, do the intersection. And we'll move those over just a little bit so we can get to that point. Alright, so smart dimension from the sharp back to the point. Stay close so we get a linear distance. And that was 25, not 35. Okay, so that gets us to the shape. 240 degrees on the angle, and did not get the second one selected. And hit Control Z one too many times. My dimension reverted back. Alright, and then 75 millimeters on a side. Okay, and the mirror will take care of that. Alright, 8 millimeters on the offset. And there again, don't know that it's actually going to be 8 millimeters if, depending on how we interpret this coming back, either as vertical Alright, so bring that parallel, and those two parallel, and then based on the dimension we get 8, and my concern is always that when I go in between those lines we're going to be a little bit narrower because of that linear distance that we're given along that edge is sort of on that face. Actually, that one does look like it went to the face. So let's go with driven, and we'll switch that one out. Other driven. That will let me edit it, and then I can make the change. So, okay. Features, extrude boss base, we'll pick the two regions, and distance is 10 millimeters. Share the sketch. Pick the region, overall height, maybe. 20 if it's on center line, that would be 40. I don't see a 50 millimeters anywhere, so we're going to go 50 millimeters. On the sketch. So let's bring this back in. So 20 millimeters if we assume that's center line, 20 and 20 and 10, that gives me 50. And that would be another one of those concern for when it gets into the assembly. See, diameter of two holes. Oh, same as? No? Well, you're given a diameter, but then did not give us a complete diameter. Sure doesn't look like 30, so let's stay with the 20 millimeter, and it'll be another one of those things that we'll have to verify. So question is, well, do we do whole wizard, or do we just do the go through? ANSI metric, drill sizes, scroll down to 20 millimeters. I'll go to an up to next and set the position. Alright, so distance in 30, distance up 20. We'll stay. S should have all of the same settings. Set the position. One I'd like to see if I can get is expand this out, show that sketch. And doesn't look like it's going to give it to me. If I can get to that center point, no. We'll just have to go 30 off of that dimension. Come back and show that sketch. Then edit this sketch. And those points can be horizontal. Okay, so first feature is driving the geometry. and then radius of 12. Well, it wouldn't exactly, depending on how they define it. If it's going to take into account the material, then this is going to be a radius of 4. 12 minus 8. So we'll make that assumption. Even at the 40 millimeters, that's still a pretty good depth to have to machine out. 4 millimeters, basically a 5/16 end mill. Okay, and 12 millimeters across the back. Now we'll go back and hide sketch 2, and that one should be good. Alright, and again, it doesn't look exactly like the picture for the isometric, but that's a little closer. Alright. .346. We get 347 up. Alright, 347 has the an angle again, and it depends on how much of that angle is going to intersect through. So I'm thinking that I'll probably draw this top geometry and then try and work back from there. So 2.5 to 3. And that is to the top side. No, and this is in inches. Okay, so top geometry, open sketch, draw the rectangle. This time the line on the end, we get rid of the vertical, kick it back, and top is 2.5, bottom is 3, and then overall is 2.5. And then to kind of help keep this in reference, we'll go ahead and extrude this down. So if it defaults up, we're going to reverse it. And then 0.31, and if we wanted to take it out, 0.3125. Alright, so drawing on this this outside edge, let's go with the parallelogram, and we'll go to the edges, grab where we think it's going to be, because it really didn't show. Let's see, that one went parallel, but I think we can get rid of it and tilt that just a little bit. Alright, if we go that to perpendicular, then 60 degrees off of the vertical is going to look like that. 2 inches on the upper edge. And then for the extrusion back, it's going to follow that edge that we just created. So extrude. Let's go up to surface. We'll pick our edge as the direction, and then the surface where it terminates be along that side. All right, we're not given anything additional in the way of information, so that looks pretty close. Let's go ahead and save this. All right, so top pattern. Another place that we can use the rectangles. Corner rectangle. Pattern is 1.5 by 1 inch, and 0.75 off of the front, and 0.75 off of the edge. Okay, I'm going to right click, select chain, and all of that goes to for construction. Alright, and then we could have done the whole wizard. We'll just go ahead and punch these through though. 0.25 and Control C and Control V, Control V, Control V. Make sure all those are set to equal. and then drag to the corner. Features, extrude cut, and we'll let it go up to next. Alright, so close to the same geometry. Yeah, it looks like it followed the same lines down. So that being the case, let's go ahead and show face. And because that's going to be a little weird on that angle, let's go ahead and extend, because it's going to work out to be a projection to that edge. And we're at the angle, so it's not going to be exact. Let's see if it's falling along. So yeah, it's falling along parallel. That's kind of what I expected. Alright, so sketch. We bring out the center lines. From there down, from there down. And then if we're following the angle, we'll have two that go that way. Alright, and 0.5 from the lower edge. And 0.75 between the intersection. So looks strange, but as long as it works. And kind of missed my intersections there, but close enough. We'll window pick, set all to equal. Could set a global variable if we needed it. But with everything, already did equal. Looking for intersections. Alright, so with intersections, we'll grab the two lines and then go to intersection. Alright, so center line, drop something there. Intersection, line, center point, intersection, line, point, intersection. So that one got coincident, or since it moves, it did not make equal. Features, extrude cut, up to next. Okay, and then we can go back and hide sketch 3. So another one of those strange parts, going to have some multi-axis. That's going to have some material that we're going to have to contend with, do something with. So all of these parts have, we really just need to look at what the capabilities, what the functions are inside of the assembly, and see if we can come up with a better way for manufacturing, make it more efficient. Alright, the strange compound angle on the corner. So we'll generate the outside shape. This is a good one for a 3D sketch. So I'm going to introduce the 3D sketch again, or also new part, and this is in metric. And one of the things with the 3D sketch, up to this point I've told you that we're going to stay away from 3D sketches, that they come with a different set of rules. Alright, so 3D sketch, I'm going to go ahead and center this. So inside of the 3D sketch, whenever you start to draw a line, you're going to get a floating coordinate system, and as you hit tab, that coordinate system is going to go from XY to YZ to XZ, or thereabouts, ZX. Alright, so as you shift through each of those coordinate systems, that lets you sketch freeform in whichever direction. If you pick a plane, it will take you into a quasi 2D plane. And I'm going to go ahead and set this as a center rectangle. And we'll set the direction for we're 50 and 44. Alright, and either that or I try that again. Oh, I guess I reselected 44. Okay, so if I want it to look like the picture, I need to reverse those. Alright, so clicking out of the plane, and when I highlight these, we have vertical on plane 6, and basically plane 6 was the top plane inside of that 3D sketch. Alright, so I want a line, I want it to be vertical, and so we're going to just bring these corners up, bring that one across. It's lying along X, so I can set a direction of along X, or not. It's not cooperating already, so that being the case, we'll go to setting equal. Alright, so direction up. Hopefully let one of these go along X. Nope. Okay, so that being the case, I'll jump back into equal. And then the lines will connect. And what I'm doing is I'm sketching in that 3D wireframe. Oh, and did I make those center line? Yeah, I did. Guess I did something there. So have the center lines. Alright, so 76 on the height. Lower edge. Now we have 30 degrees on the corner, so so the reference dimension isn't popping up inside of the 3D sketch, or I'd have to make a go ahead and make it a 2D sketch on that plane, or generate a plane there. So we'll just take the adjacent angle of 60 degrees, go ahead and put that in place. Alright, so then one angle goes from there to there, one from there to there, and one from there to there. So what that does is it gives me a sense of the geometry, where we're dimensioning from. So 26 at the bottom, and 16, and then 27, right, and then from the center to the vertex. So from there to there, and from there to there. And I don't think I did that right. So we have a dimension of 12 and 14. I don't know that that's going to be the midpoint, so we need to pull that back. We'll just make sure that it's coincident. Pull that back. It stayed coincident. Alright, so into the dimension, point to point, and it's trying to lie along that edge. So not exactly the desired result. So let's drop a center line that we can drive to. Alright, and that is an along Y and an along Y. Okay, so 14 millimeters and 12 millimeters. Will be the intersection of that face. So where is the midpoint? Select midpoint. Just so happens that that midpoint is pretty darn close, so we could have gotten away with the midpoint. Right? But given the dimensions, without the inference, we kind of have to go with that. All right, so since this isn't part of the assignment, it's a kind of the concept. Let's take it to another level. I'm going to make this even more complicated. We're going to do this in surfaces. So one of the things that SolidWorks does, as a matter of course, is when we generate a solid, it's generating a watertight volume for our solid, and it consists of these surfaces. And then in the end, the geometry is once it's watertight, it gets thickened or filled, and the outside surfaces are kind of a secondary item. So I want a Let's see, filled surface or boundary surface. So 3D sketch, no, let's just go with the boundary. And so whenever we see the, what is this one called? The selection. We're going to make those picks. And because these are multiple lines in the same, so that would be one method. And basically a planar surface. Oh, I really didn't want it to consume that. Alright, so let's see if we can share it again. An extruded surface then would be the selected contour. Only thin features are permitted. And so that did not give me the edge. So I think we're going to have to stay with boundary on that one. Alright, so line, accept, and these don't have any curvature to them. So I wonder if that's good enough for the selection. Alright, so we can do 2. There it is. There's a planar surface. So bounding entities, if it'll allow me to select. No, probably not. Now it's going to try and pick everything. So the planar surface would be if I had an enclosed region. And even I don't really think that's going to apply, so we'll see. Nope, just too much geometry. So unless we want to create sketches with cleaner geometry, I think boundary surface is going to be our best choice here. So first item in the selection, second item in the selection, go ahead and create. And it found my my center lines. Okay, well that fills it up, creates it. So how about the vertical then? Nope. All right, so again, maybe just getting too complicated in the selection or the angles. Okay, so we've got all of our kind of the planar surfaces, and notice that we're starting to accumulate boundary surfaces. All right. So direction 1, and oh, nope, needed to jump over to the next one. Okay, that'll work. Got a little button happy there. Continuous group of entities. Okay, so let's clear selections and start over. It's still picking. Interesting. Alright, well we'll stay with that. See if that's happy. Nope, it crisscrossed. No. So first selection, second selection, I'm getting out of sequence here. Alright, so pretty wild. Alright, so all that goes in. Let's see if, nope, we kicked out the planar surface, the boundary surface. Self-intersecting geometry, so it's trying to loop back in on itself apparently. See if it likes just one edge. Triangles are interesting monsters there. Alright, so I have surfaces, I look at the wireframe, and the interior. We see those surfaces, but basically there's 7 surface bodies now that are creating that geometry. So I tell it to trim the surface, the trim tool, and actually, it was surface 9. Okay, is the angle, and we're going to keep selection, so I want to keep that face and let it trim. Okay, so I can kind of see down into that now behind the box. And trim surface, trim tool is surface 9 again. Keep selection, trim. And trim surface, nope, clear selection, And it's updating the names, so I'm losing kind of track of my selection. Alright, so we hide the wireframe. Under boundary surface. Yeah, at some point we want to save this. Okay, so the fun part, we're going to knit all of these surfaces. Selections, highlight, make sure everything's in place. What knit surface does is it creates one connected surface. If that surface is watertight, then it can also create the solid. It's looking for gaps and tolerance to complete the geometry. All right, so the long way around then is I have all of my surface geometry, which I can then add to a new folder. And the one surface net that actually creates the solid. I can tell that it's a solid. Let's go back just a little bit and do a cross section. All right, section view just looks like a hollow box until I roll back in front of the surface net. All right, so that gave me my angle. And again, more for an example of dealing with the surfaces. Usually there's a couple more that I can fit in there, but the boundary surface worked pretty good with the geometry. So I'm going to show, and hopefully I can rotate this around to where I can pick up that center line. And then it's going to be 8 millimeters, 20 millimeters deep. Alright, so where would you use surfaces over just going ahead and creating the solids? The more ergonomic, the more the planar surfaces fail. You're looking at the planar solids fail, then that's when you're looking for getting into this this geometry. So anything that has the waves, has more intense geometry, would lean towards the other surface. Anything that is loft or swept, but then the lofts and the sweeps start varying in thickness and size as they go. Surfaces have less of an issue with those variations. So again, not the best example, but a good starting example of I created a wireframe, we put the surfaces on it, and that selection tool. Now that I think about it, let's go back into one of these. And that selection tool is called the selection manager. And so when you see this, you have more than one possible selection in the geometry, and it's asking you to clarify. All right, and your options are closed loops, open loops, and then various groups. All right, so different way of looking at it.